Are you excited about mastering VMware Secrets Manager? So am I. In these video tutorials, we'll dive into how you can register secrets to workloads in various use cases. If you find value in what you learned today, please give us a star on GitHub at github.com/VMware Manager. Your support helps others discover this incredible technology. Before we begin, here's what you need to know. We will demonstrate these tutorials on an Ubuntu virtual machine. If you are going to follow along with me, I recommend using a similar operating system for a flawless demo experience. The steps to install and run Minikube will slightly differ if you use Mac or Windows. You have two options if you use Mac or Windows. Either use a Linux virtual machine to keep the process consistent with the examples in these tutorials, or follow Minikube's official instructions. If you prefer to use your current OS, consult Minikube's official page for specific guidance on Mac or Windows. After installing Minikube on your system, the rest of the tutorials shall work without problem. If you still have issues with Minikube, check out the Minikube quirks section in the VMware Secret Manager's official documentation, as it might give additional tips to help you fix your setup. Please choose the best option for you, and let's get started. In addition to Minikube, you'll need Git, Make, and Docker. Having sorted out the prerequisites, let's proceed with the setup. I am in my project folder, and I've already cloned VMware Secrets Manager's recent source code using git clone, https github.com, VMware secretsmanager.git. Let me execute a git pull to ensure we have the recent updates, and everything is up to date. Now, I'll run make help to get a helpful summary of the make targets I can use to do various build tasks on the project. To use VMware Secrets Manager, we'll need a Kubernetes cluster to deploy it. For our demo purposes, I'll provision a Minikube cluster, though keep in mind that VMware Secrets Manager can work in any Kubernetes cluster. As I've mentioned in the beginning, I'm on an Ubuntu Linux server. If you are using a Mac or Windows system, there might be slight differences in the steps you take while installing Minikube. However, once you set up Minikube, you can follow the examples in these videos without any issues. First, I'll run make-delete to prune any existing Minikube cluster we might have. By the way, if you are curious about where these make targets are, check the Makefile in the project root. When you check out the file, you'll see that it is logically split into several includes, all of which can be found in this Makefiles folder. In our case, the make-delete target is defined in this vsecum deploy.mk file, and it just calls the hack minikube delete sh script. There is a list of scripts in the hack folder, mostly called from these make targets. Our minikube delete script does what it is supposed to do, and deletes Minikube. I'm showing this so that if you are unsure about what sequence of actions happens when you execute a make target, you'll know how to locate it in the source code. Having purged the cluster, let's create a new one. Make start. Well, I got this error because I have Docker Content Trust enabled. To install Minikube, I'll need to set Docker Content Trust to 0. Docker Content Trust is 0 by default, so you won't likely encounter this outcome. But if you do, you'll need to temporarily set Docker Content Trust to 0 to be able to install Minikube on your system. And when we run make start, it starts installing Minikube for us. Next up, I'll run this eval statement. I don't typically need it, but if I need to use a local image for debugging purposes, then I'll have to run this line on my shell so that we can use the internal Minikube Docker registry. In any case, running it won't hurt and can help us later down the line if we want to build and debug things locally, so I'll copy this, paste on my terminal, and press enter. If I want to build everything locally, I can run make build local. However, I won't need it most of the time because we already have container images in Docker Hub pre-built for us that we can fetch and install. I'll run make build local to show you how it looks, but you won't need it unless you change the source code and need to recompile VMware Secrets Manager. The build process will take a long time, as it will build and package the entire project. I'll fast forward with the magic of video editing to save us time. Since I just built all my local images, I can deploy VMware Secrets Manager from the local images on my Minikube local registry. For that, I'll run make deploy local. By the way, deploy local uses the default distroless images. If you are running in a restricted environment that requires FIPS compliance, then you can deploy FIPS compliant images using deploy FIPS local, or you can use VMware Photon OS base images by executing deploy Photon local, or for FIPS compliant Photon images, you can use make deploy Photon FIPS local. Also, instead of the local registry, if you want to deploy existing images on Docker Hub, you can run these targets without the -local suffix. So instead of make deploy local, if you just run make deploy, you'll install the images from the public Docker Hub registry instead of your local. The same goes for deploy FIPS, deploy Photon, and deploy Photon FIPS. And that's the end of this section, where we covered several ways to deploy VMware Secrets Manager to your clusters. Next up, we'll dive into the architecture of VMware Secrets Manager a bit. And until we get there, keep your secrets secret.